Hello dear students, and a very warm welcome to one and all once again in the session where we are together here and we are going to solve the numerical based on the NEET pattern for the chapter 13 from your NCERT, and the chapter is nothing but the nuclei. As we are covered with the session of theory part, we have almost covered the theory, and now it is time to just check out whether we are able to solve the question based on the NEET pattern or not. Because I know that your exam is just around the corner and you are worried about your exam. So let me tell you, my dear students, if you are going to solve such numericals, if you are going to just pick up the previous year question papers, just sample papers that is going to be arrive in the market nowadays, you are going to attain a good marks. Because the practice makes a man perfect. And how you are going to practice them? By solving the previous year question papers and also by solving the sample papers. Here I have brought something for you, that is the combination of previous year papers and the sample papers, that means the new questions. So we will be going to solve it together here, and now without wasting much of our time, we will be just moving toward the first question of the session. And let me just see what is the first question. Alright. Since it is a NEET pattern, so you are going to see the question which will be related to somehow CBSE pattern. That means the level will not be that much tougher. So if you are going to do, if you are going to practice them very well, you can score a very good marks. Because if you are practicing the question regularly, your speed will be smooth. You are going to have a swift speed of yours. So now let us begin the question number 1. Alright, so I am going to read the question for you. We can see here it has been written that the activity of a radioactive substance at time t1 is A1. Now one more thing that I just want to tell you, that whenever you are going to read the question, the first thing that you should do is just note down the main points that has been given in the question. From the very beginning that you are starting, that you have started reading the question, just note down the main points. Because it is a case that you must not miss any important thing that has been provided in the question and you would have forgot to apply that. So that is why we will be going step by step. That means first of all we will be writing what are the values that has been given. So for a radioactive substance, we have been given a one radioactive substance, and at time t1 its activity is A1. So we will be writing it at time t1 activity is A1. Now at time t2 the activity becomes T2. So we will be writing it as at time t2 the activity is A2. Now if the mean life of the substance has been given that it is Tm, this is the mean life. Let me just write over here, the mean life has been given as Tm. And what else has been given? Then the number of atoms decayed during the time interval T2 minus T1 will be what? We have been given the 4 options and we have to choose any one correct answer. The correct answer will be only one. So that means you have to be very particular, you have to be very accurate. So that means we will be now starting the question and we will see how to proceed for the question. Because now here what has been given? The mean life. And you know what? The mean life is, if it is a decay constant, you can represent the mean life as the reciprocal. That means if I am going to write the mean life, the reciprocal of decay constant is your mean life. Now in the question we have been provided with the activity. And you know that we are having one formula with us where we are going to use the activity and number of atoms that has been disintegrated, or you can say the number of atoms that are left with us. So we are having one formula, and that is A equals to lambda n. where let me just say that if suppose you were initially having n naught number of atoms or n naught number of nuclei, after the disintegration it would be something else, and the atom that has been left after the disintegration, that will be the n. Here lambda is your decay constant, A is activity. Now let me just tell you one thing, if I am having this formula with me, I can write this lambda as 1 upon Tm. So let me just convert it into the form of lambda into n. Now what you can do from here, your n will become A into Tm, isn't it? It's just a simple thing, you are just making the formula in another way. So we have written n equals to A into Tm, that is the mean time. Now we have been given the activity as A1 for time T1, A2 for time T2. So that means your N1 will be A1 into Tm. Tm is the mean life. So mean life will remain same. So N2 will be A2 into Tm. Now because we have to find, just look back the question, look it back. We have to find the number of atoms that has been decayed during the time interval. The number of atoms that has been decayed. That means if I am going to find N1 minus N2, this is what? This is your number of atoms that has been decayed, right? So now what we can do over here is, we just know the value of N1, we will be putting it will be A1 Tm minus A2 into Tm. Now if you will be taking the Tm, that means the mean time as common, so you will be having A1 minus A2 into Tm, and this is nothing but your number of atoms decayed during the time interval, right? Because now your question, I'm just imagining your question from me would be that, ma'am, we have been given in the question to provide the number of atoms decayed during the time interval T2 minus T1. So let me just tell you, my dear friends, we are having one formula with us, that is n equals to n naught e raised to the power minus lambda t. Now if you want to find the number of atoms decayed in time interval T1, so you will be having n equals to n naught, say n1 it is, e raised to the power minus lambda T1. Similarly, if you want to find for n2, that will be n naught e raised to the power minus lambda T2. Now what you can do from here is, since you are having your time periods with you, you are having your activity with you, you are having your initial number of atoms with you, you can easily find out the number of atom that has been decayed. So I think I must would have cleared your doubt, that is the time interval T2 minus T1. So you need not to worry, because the activity that we are using here, it is just corresponding to that time period. Like A equals to lambda n. We have used A1 T1, sorry the Tm, A2 into Tm. We are now taking the mean average life. So that means you need not to worry about the T1 minus T2, it is that only what we are doing here. So the answer of the question will be A1 minus A2 into Tm. Now let us just go back to the options and verify whether this option is available or not. A1 minus A2 into Tm. So if I can see that option number 4, that is the D option, A1 minus A2 into Tm is available here. So that means this must be the correct answer, right? So yeah, we have covered the first question, and this is the way how to proceed in the question. In this chapter, as I have told you, important thing is radioactivity, half-life, mean life. That means if you are aware of all the formulas that is used in this, you can easily solve all the question. And for solving the question, the important thing is you must be remembering that formulas. And I have told you in the previous lecture how to remember the formulas. Just make a paper note, write down all the formulas over that and paste it on the wall which is in front of your bed, so that whenever you will wake up in the morning, you will see that page and you will focus on that. It might happen that 1 or 2 formulas will be remembered by you in the morning. So that means this is the way how to remember the formulas, because when I was student, even I am also a learner right now, but when I was a student, I was just following the same trick to just learn the cram up the formulas, because there is no way to make anything simpler. To learn the formulas, you have to cram them up, and to cram them up, you have to regularly see them, right? So now we are done with the first question, and it's now time to just watch out what will be the second question. Okay, so the second question that I can see over here is that we have been given a radioactive material of half-life T. That means T half, or you can write it as capital T as, or you can say it has been given as capital T. It was produced in a nuclear reactor at different instants. Now, the quantity produced second time was twice of that produced in the first time. Okay, so we got that. Suppose if initially it was N0, first time it became N1, and for the second time it would happen that it will be 2 times of N0. That means twice of that produced first time. So let me just write here 2N1. I am not going to use these statements, I am just writing it because it has been given. And after that we will see what we have to do. Okay, so then next, if now their present activities are A1 and A2 respectively, then their age difference will be what? We have to tell them the age difference, and age difference is what? T1 minus T2. This we have to find out in the question. So now let us just begin with the question that has been given, the values that has been given, and just give them the accurate answer. Because me and you, we are going to do it together. So bring out your calculators and solve with me together. So now what will be? You know that if there is a word activity, one formula should be directly came to your mind, and that formula is A equals to lambda n. Now what we can do over here, we know that n equals to n naught e raised to the power minus lambda t. You know this? I hope you all are aware of these formulas. You all are familiar with these two formulas. If you are clear with the concept of chapter nuclei, it is 100% sure that you will be familiar with this formula, right? So this is nothing but the radioactive decay law, or you can say dN by dt equals to minus lambda n. By using that, you will be finding out this. N naught is initial number of atom, n is your final number of atoms. So we are having this formula. Now what we will do, because we know that your N1 was N naught e raised to the power minus lambda T1, and if I say this is for A1 equals to lambda N1. Now if I will be saying for A2, that will be A2 equals to lambda N2. Now you know that N2 for this case is, because we have written for the second case, just look at back, second time was twice of that produced the first time. So we will be writing here as N2 equals to 2N naught e raised to the power minus lambda T2. Now we are having these relation with us. For this first relation, what I am going to do, I will be putting this value of N1 into this equation. So my equation will be becoming A1 equals to lambda into N naught e raised to the power minus lambda t1. Now what we have to do? We have to find out these t1 and t2. And to find out this t1, what I can do from here is, just look at here. If I'll be taking log of this equation, what will I have? If I'll be taking log, you will be having log a1 equals to log lambda into log n naught. So if I'll be using, if you can see, they are all in the multiply. They are the product. So what happens in the case of log? If you are going to take a log of all these three terms, they are going to be added separately. So log lambda plus log n naught plus log e raised to the power minus lambda t1. Now what will you see? If I will be taking the log of this log and exponential term will be cancelled and we will be having only minus lambda t1. So, and basically if they are in multiplication, I can combine them together. So I will be having log lambda n naught. This is not, please do not get confused, this is not in division. I have just make an underline for that. So this is log lambda n naught minus log and exponential cancelled, you will be having minus lambda t1, right. So now we will now see how to do it further. Just make it separate because we are going to use that also. So after that, your step for this question will be log a1 equals to log lambda n naught minus lambda t1. Because I have to find out the value of t1, so I will be taking this value to that side. That means lambda t1 will be equals to log lambda n naught minus log a1. Now you know that when we are having some log in the minus, we will be writing it in the form of division. So we will be having lambda n naught upon a1, isn't it? Now to find the value of t1, what will I do? t1 will be 1 by lambda log lambda n naught upon a1. This is your value of t1. Now what you can do over here is, you can put the value of 1 by lambda. You know that the half-life, the capital T, half-life is log 2 by lambda. And from here, to find out the value of 1 by lambda, you can write it like T by log 2. So we will be putting this value into this equation, that is 1 by lambda equals to T by log 2. So that means you will be having your T1 as T by log 2 into log lambda n naught divided by a1. This is the value of your T1. Let me just mark over here. This is your T1. Now similarly, the value of T2 will be same, but the difference in that will be what you are going to use in here. In the place of lambda n naught, you are going to use 2 n naught, because in the question it has been given that it was the second time, it was twice of that produced in the first case. So for that we will be using twice of n naught. Here I have written. So that means if you will be putting this value 2 n naught in place of lambda n naught, let me just, if you want me to write that, the complete equation will be same, but the difference in that will be only 2 is going to be added over here. So I can basically write the final equation for you. Your final equation will be T2 equals to, just come with me and speak with me, what will be the T2? T2 will be T upon log 2, T2 will be T upon log 2 log of lambda 2n naught. For the second case, it will be lambda into 2n naught divided by A2, because we are taking the case of A2. So that means this will be the equation for T2. Now we are having finally the equation for both T1 and T2. After finding this both equation, we can say that because we have to find the difference, their age, so that will be T1 minus T2 definitely. I have written over here, you can see that in the question we have to find the age difference. So T1 minus T2 we have to find. Now because I am having my T1 and T2, I am going to use this T1 and T2 to find T1 minus T2. Okay, so T1 minus T2 will be, let me just start from here. Your T1 minus T2 will be, just consider that value T by log 2 into log of lambda n naught divided by A1 minus T by log 2 log of lambda 2n naught divided by A2. Now the question has become very much simpler because we just have to now solve it. And how to solve it? Wherever you are going to use, wherever you are going to see the log in the form of minus, you will be taking it into division. And wherever you are going to see it into division, you will be using that in a negative manner. So that means if I will be taking T by log 2 as common, we will be having log lambda n naught by A1 minus, since it is minus, you will be going to take it into division, because let me just write for you here just in a short while I can tell you, division converts into minus sign. In the case of log, division converts into minus sign. Multiplication converts into positive sign. So that means because it was here minus, so it will be converting it to, it is interconversion. So it will be converting into division. So we will be writing it as log lambda 2n naught divided by A2. You are having this with you. Now what you will do? T by log 2 log of lambda n naught and lambda 2n naught. When you are going to multiply them, you will see that n naught will cancelled, lambda will cancelled. You will be having your, after solving you will be having your T1 minus T2 as this. So let me just verify whether this question, whether this option, this answer is available in the options or not. So let me just revise it. T by log 2 log of A2 upon 2A1. T by log 2 log of A2 upon 2A1. So yeah, definitely we can say here this is the correct answer. The option number C, this will be the correct answer. So this was the way to start this question and to solve this question. The question was very much simpler. I have took time, I have taken my time just to make you understand. Otherwise, if you know the concept, if you know the formula and you are going to attempt it, there will be hardly 1 minute for this question, not more than that. So now we are done with this question and we will now see what will be the next question with us. Okay, so here I can see that we are having a question from X-ray, because from here I can see that electronic configuration of zinc in the ground state is this. Then the electronic configuration of zinc immediately after the emission of K alpha line is what? And you know that we have read that K alpha line in the case of X-ray spectrum. The characteristic X-ray spectrum was based on what? The K series, L series, M series, N series. And again we are going to discuss it here, because to make this concept, to make this question clear to you, I have to make you understand that. So let me just tell you first of all what was the okay, so first of all let me just write the configuration that has been given. 1s2, 2s2, 2p6, it's 3s2, 3p6, 3d10 and 4s2. We have been given this, and the question is, when the alpha emission is going to take place, the K alpha is going to take place, what will be the electronic configuration? Let me just tell you once again what do we mean by the K series. As you have seen in the case of X-ray, when you are having this nucleus with you, right, now in this case when electron is going to hit the target, then what will happen? If suppose an electron is coming and also one, 2, 3, 4, 5, 6, 7 and 8. 2 in the inner shell, 8 in the outer shell, and let me just write and make 2 more electrons in the outer shell. Now when the electron hit the target, electron directly penetrates through the atom, and what happens? It will remove the electron, it will knock out the electron from the innermost shell, that means the K shell. Let me just write, this is your K shell, this is your M shell, this is your N shell, KLM shell. Now when the electron will come, it will directly come and remove this electron from the innermost shell. Now because this electron has been removed, so that means there must be a vacancy now. Let me just remove from here, because now electron has been removed. So that means you are having one vacancy here. When there is one vacancy, what will happen? The electron that are present in the L shell or the M shell, that means they are present in the higher shell, they will come to the inner shell and fill this vacancy by their presence. Suppose if this electron was removed, it was knocked out by the electron, then in that case this electron that is present in the L shell, it will come and fill this space. Let me just write over here, say this is electron from the L shell. Now what happens is, whenever, let me just show you here, say this is K shell, this is L shell, this is M shell and N shell. Now whenever if the electron from the L shell is coming to the K shell, suppose it is coming from the L shell and falling into the K shell, that will be your K alpha series. Any of the atoms, any of the electrons that is coming from any higher orbit to the K shell, that will be making the K series. So let me just make it for you. So this is your K series. And when the electron will be coming from higher orbit to the M shell, that will be your, okay, so let me just tell you firstly for the L shell. Since it is L shell, so when electron will be coming from any higher orbit to the L shell, that will be your L series. And when it will be coming from any higher energy level to the M shell, that will be your M series. Similarly, it just goes on. Now what is K alpha, K beta, K gamma? In the question we have been given the K alpha. That means your electron, when it is coming from the L shell to the K shell, that will be your K alpha series. When it is coming from M shell to the K shell, that will be your K beta series. And when it is coming from M shell, the N shell to the K shell, that will be your K gamma series. Similarly, it happens for the case of L series, for the case of M series, for the case of N series. That will be your alpha, beta, gamma. And now in the question we have been given this K alpha series. That means if the electron will be coming from the L shell to the K shell, that will be the K alpha series. So in the question we have been given this configuration. You know that this is your K series, this 2 is your L series, this is your M series, and this will be your D series. Now what you can see here, if I will be writing n equals to 1, 2, 3 over here, says it is 1, this is 2, this is 3 and this is 4. So the number that has been written over here, this 1, these are 2, these are 3 and this is 4. This is nothing but the quantum number, that means your orbit number. And when it is coming from, I was saying that it is coming from the L shell, that means the electron must be removed from this shell for the K alpha emission. Now to remove this electron, we are now on the step that we should know from where to remove the electron, whether it will be removed from 2s2 or it will be removed from 2p6. So let me just tell you, my dear friend, if you know the concept of Bose principle in your chemistry, that means electron is going to be removed from that shell which will be far away from the nucleus, and which the shell will be closer to the nucleus, it will be having higher energy. That means if we want to remove the electron from the shell, that must be far away from the nucleus. So that means electron must be removed from here. And when electron will be removed from here, the configuration will become as 1s2, 2s2, only one electron is being removed. So it will be 2p5. Similarly, it will be same because only one electron is being removed. So all the electronic configuration, the rest of the configuration will remain same. So it will be 3s2, 3p6, 3d10 and 4s2. Okay. Now one electron has been removed from here, so it has now become 2s2, 2p5. Now let us just see whether there is any option available in the given options or not. So 1s2, 2s2, 2p5, 3s2, 3p6, 3d10, 4s2. That must be the correct answer. So I can see over here this option number C. It is the correct answer because here 1s2, 2s2, 2p5. In all other configurations, I cannot see the same answer that I have got. So this must be your correct answer. So yeah, we are done with the question number 3, and we will now see what will be our question number 4. Alright, so now here what are they wanting us to tell them that in an atom bomb, the energy is released due to which option? The chain reaction of neutrons with this isotope, the chain reaction of neutrons with this isotope, that means U-238, the chain reaction of neutrons with 240 or with 236. Now I can see here there are 4 isotopes of uranium. But what I know that uranium has isotope U-235, 233, 238. Now we will be using here the reaction that we have studied in the nuclear chain reaction, as I have told you in the theory, and also for the competitive exam I have made you this question very much clear. what is the nuclear reaction? Let me just again tell you, we are going to rub this and we will be starting with the nuclear chain reaction. Now, you know that whenever a fast moving neutron is going to hit a uranium isotope, 3 neutrons are definitely going to emit out. So that means what I have to do, if I will be showing you this reaction, suppose it is U-235 and it is being hit by the neutron, what will happen? We will be having barium with us with mass number 141, the krypton with us with the mass number 92, it is 56 and it is 36. Along with that, we will be having 3 neutrons and plus lot of energy. Now what is nuclear reaction? You can see there are 2 fission products. One compound of one isotope of uranium is taking fission in the form of 2 fission products. So let me just show you here. If this is your, let me just make this more clear to you by making it here. If one neutron is coming and it is hitting a U-235 isotope, now in that case you will see these 2 will become the fission products. That means these are nothing but the barium and krypton that we have made in the reaction, that we have shown in the reaction. So these are your fission products. I am writing it as Fp. Now in this case you have seen 3 neutrons are coming out. We are going to represent these 3 neutrons as 1, 2 and 3. These are nothing but the neutrons. Now when these fast moving neutrons are going to hit further 3 isotope, again this will be your fission product. And these will be 3 neutrons. This will be your fission products. And this will be your 3 neutrons. Again, here will be your fission products and these will be 3 neutrons. Now you are having this figure before you where you can see one fast moving neutron is hitting this isotope and it is showing that 2 fission products are getting and 3 neutrons we are getting. The 3 neutrons, the secondary neutrons that are coming after hitting them after this emission, these are fast moving neutrons. And because this fast moving neutron is able to further proceed the reaction by hitting them and by giving them more neutrons, that is why we can say only U-235 is able to show the nuclear chain reaction. Because for the reaction of U-238, you will see you are not going to have this controlled chain reaction, right? So that means if you want to make the atom bomb, you have to proceed the nuclear chain reaction because these neutrons are going to multiply every time. Here you have seen there are 3 neutrons and here you can see there are total 9 neutrons. So 3 multiplied by 3, that is 9. Every time they are getting multiplied. So you can imagine how much number of neutrons we will be getting if we will be having the continuous chain reaction. So that means we will be saying that U-235 is the source of the atom bomb. So energy released is due to the chain reaction of neutrons with U235, right? So yeah, we are now done with this question. We will be looking at the next question, that will be the question number 5. Alright, so the question number 5 that I can see from here is the nucleus of element X, whose mass number is 220, it undergoes an alpha decay. If the Q value of the reaction is 5.5 mega electron volt, then what is the approximate kinetic energy of the alpha particle? We have to calculate the approximate kinetic energy, right? So we have been given the Q value. We know that one reaction is going to be proceed. Let me just start with the reaction. Alright, so what I can see over here is the nucleus of element whose mass number is 220. It undergoes alpha decay. If it is going under the alpha decay, the product will be what? 2He4 plus 1 nuclei whose mass number will be reduced by 4. So 220 minus 4, this will be the next product. Now we have been given the Q value and we have to tell them the kinetic energy. Let me just tell you, this is the simpler question. No question can be easier than this. You are given the Q value, you are knowing the mass number, and you can easily find out the velocity. Sorry, the kinetic energy. But yeah, for the kinetic energy, we need to know the velocity. So we will be just now here, what will we be doing? We know that Q value is nothing but the mass of products minus mass of the reactants into 931 mega electron volt. So first of all, because we have been given the, only the Q value has been given. So what we are going to do, we are going to multiply their masses. These are products and this is our reactant. So product is plus 220 minus 4, that is 216. Now what we will see here, we have been given the 220 as the mass number in the case of alpha decay, and we have been given the Q value. Now if we are going to use the Q value in place of this Q, we will be writing the 5.5, and what we are going to do here, let me just remove it when we will be starting it again. We know that this is an alpha particle and this is the new product particle. Its mass number will be 216 and its mass number is 4. So here what we are going to do, we are going to multiply it with the Q value. If we are going to multiply them, what we will be getting? Okay, so let me just tell you another alternate solution for that. We know that if we are going to use the conservation of momentum, so that will be m1v1 equals to m2v2. Just forget all things. Forget all things. We are going to use the alternate method because this is the easier method. We have been given m1 equals to m2v2. Now in the case, I will be seeing that this product, because it is disintegrating, that must be at the particular position. That means its velocity will be 0. So we will be writing it as 0 equals to m1 into v1. So let me just consider this as my m1. So that will be m1 into v1 plus m2v2. m2 is 216 into v2. Now from here you can see that we are having 41 equals to minus 216 v2. So because we know that we are going to find the velocity, we will be taking it positive, because velocity here So because to find the velocity, V2 will be 4 by 216 into V1, isn't it? Because we are finding the V2 here. So divide this V2. Yeah. So we are having our V2 as V1 upon 54. Now we know that because we have to find out the kinetic energy. We are having our V2 as V1 by 54. Now we know that we can put it as kinetic energy, that Q value as half m1 V1 square. Your m1 is again 4 into V1 square plus half into m2 into V2 square. Your V2 square will be V1 square divided by 54 square. Now if you will be going to multiply it over here, you will be having your 21 square plus, and if you are going to solve for this, you will be having your, so finally you will be having your velocity as 2.0037 into V1 square. Now from here what I can say, the V1 square will be equals to 5.5 into 2.0037. This is my V1 square. Now because I have to find out the kinetic energy of the alpha particle. So the kinetic energy of alpha particle will be half m1 V1 square. So because we know that V1 square, we know the mass, so we can easily find out the kinetic energy. Half into m1. m1 is nothing but the 4. V1 square. V1 square is nothing but 5.5 divided by, I am just putting this complete value. And what you are going to do, you are now going to bring out your calculator and start doing it with me. Because till here we are now reached at the position where we are just going to put the value and get the answer. So it just depends on you. Whatever the value you will be getting, that will be your final answer. So if you will be solving it with me, you will be seeing that we are having our energy as 5.4 mega electron volt. Now the main important thing is that we have reached at the correct point or not. By the multiplication, simply you will see that your value is 5.4 mega electron volt. But now we have to verify whether this option available or not. So we will be proceeding towards the question and we will see, yeah, we are having one correct answer, and that is 5.4 mega electron volt. So this is the way to just start the question. We should be knowing that the Q value is nothing but the energy. So that is why we have written this Q value into the form of 5.5 equals to half m1 V1 square plus half m2 V2 square. And we are using this in this manner because we have to find out the velocity. So you have to focus on one thing, how do you can use the one particular formula in another way. You just have to be dependent on the situation of question. You are having number of formulas before you, but how to use them wisely, it just depends on you. It just depends on the situation of the question, and it just depends on the presence of your mind. So that means it depends on you. Now we will be just solving the next question. Till then we will be starting it and watching it out. Okay, so we have now covered the 5 questions from this session of the NEET. Now we will be moving towards the 6th question, and let us just see what is the next question before us. Okay. So I can see that we have been given the question from the topic binding energy. The binding energy per nucleon of 7,3 lithium. That means the mass number of lithium is 7, the atomic number is 3. and for the helium nuclei are this and this. Let me just mark over here. In the nuclear reaction, the reaction has been given to us. The value of energy Q released is what? So basically we have to find out the energy, the Q. Now let me just tell you again, previous question that we have done related to the energy from question number 1 to 5, we have seen that there was a question where we have seen the Q point, the Q energy, and that Q energy is what? The mass of energy of products minus the mass of the total mass of the reactant. Let me just repeat myself, the mass of products minus the mass of reactants, or you can say the energy of products minus the energy of reactants. So we will be doing this formula and I am going to write it before you. Let me just write over here, what will be the value of Q? We have been given the binding energy per nucleon for the lithium and helium. Let me just first of all write down this reaction. This is plus 1H1. It is giving 2 helium atoms, nuclei. So I am writing it as 2He4 plus Q has been coming out. That means the energy is coming out. We have to calculate this energy. Now to calculate this energy, we have been given the binding energy per nucleon. Now in the previous session, I have told you how to calculate the binding energy if you have been provided with the binding energy per nucleon. So let me just tell you, multiplied by the mass number, it will give you the binding energy. So to find out the binding energy for the mass for these reactant and for the products, we will be writing here as Q equals to, Q will be what? I have told you that Q is nothing but the mass of products minus the mass of reactants, or the energy. You can say it in terms of energy. So the energy of products minus the energy of reactants. So Q will be energy of products. So 2 multiplied by, what will be the energy? Binding energy is binding energy per nucleon multiplied by mass number. So for the helium, we have been given the binding energy per nucleon as 7.06 mega electron volt. This is for the helium. So let me just write over here 7.06 multiplied by 4. Binding energy per nucleon multiplied by the mass number. Minus, now you have to minus because in the products you are only having this helium particles, the 2 helium particles. Now here in the reactants you are having hydrogen and lithium. Because in the question we are not provided the binding energy per nucleon for the hydrogen, and also I can just tell you that the binding energy per nucleon for the hydrogen is 0. So we can totally ignore this. Now we are having only this with us for the reactant. So we will be multiplying this, the mass number multiplied by the binding energy per nucleon. So the binding energy per nucleon for the lithium is 5.60 mega electron volt. So we will be putting this value 5.60. So if you will be multiplying it, you will be having it as 56.48 minus 39.2. Now if you will be solving it, you will be getting the value of Q. So let us just solve it here. If you are going to solve it, you will see that this value has came out to be into the range of 17.28. So let me just write over here 17.28 mega electron volt. Now let us just verify whether this is present in the option or not. So we can see that in the option 17.3 is present. That means this is the closest value to the option. So we are going to tick over 17.3. So this must be the correct answer. Now you can see how easier this question was. You just have to know how to find out the Q value. Energy of products minus the energy of reactants. Only this much you have to do. And then you have to find out the energy, the Q. So that is the way to find out the Q in this case, and we have summarized this with the answer 17.3 mega electron volt. So now we are done with this question. Now we will be moving towards the next question. Just let us see what is the next question before us. Alright, so the question says that a radioisotope X with a half-life of 1.4 into 10 raised to the power 9 year, it decays of Y, which is stable. X is decaying into Y. A sample of the rock from a cave was found to contain X and Y in the ratio of 1:7. Now the age of the rock is to be calculated. We have to calculate the age of rock. Now you can see here we have been given the mass in the ratio of 1:7, because they are saying that a sample of the rock from a cave was found to contain X and Y. So what do we mean by it is containing X and Y? Definitely that will be the mass of X and Y. So suppose let us suppose mass of X is mx and mass of Y is my. Now in that case, what has been given in the question? We have been given this ratio that the masses are 1:7. So let me just write over here mx ratio my equals to 1:7. Now let me just tell you, these are the parts of one radioactive substance. There was a radioactive substance X, and when it is decayed, it was break down into X and Y. This X must not be having the same mass number as this X, but in the question, as we have given that this X is breaking down into X and Y, so what we will do? We have seen that it is breaking down into 2. Now we will be saying that suppose initially the radioactive sample was having mass N. Initially the sample was having equal to M. So after the disintegration, after the decay, what will be the mass? M will be equals to mx plus my, isn't it? Because this was the initial mass, and when it was break down into 2, we can say that this total mass will be equals to mx plus my. Now we have been given this ratio. We can write this as mx upon my equals to 1/7. Now from here you can write one thing, that my equals to 7mx. Now because you are having your my equals to 7mx, if you are going to put this value here, what you will be having? M equals to mx plus my. My is 7mx. So that means your total M is equals to 8mx. So now what you can see here, your mx has came out to be M upon 8, or you can say 1/8 of M. isn't it? Your mx will come out to be m upon 8, that means 1 by 8 of m. Now let me just go back to the question and we'll just verify what are they asking us. They are saying us that a sample of the rock from a cave was found to be containing the ratio x and y in this 1:7. So we have to calculate the age of the rock. So that means we have to find out the T. Now we have seen that when the mass has been decayed to this much and we have been given the half-life as 1.4 into 10 raised to the power 9 year. That means capital T has been given as 1.4 into 10 raised to the power 9 year. Okay, so let me just tell you one thing. When the mass has been decayed to this much and initially the mass was m. So let us just do one thing. Initially that was mass m. After one half-life, it will be becoming m upon 2, isn't it? Because after the half-life, the mass will be just the half of the mass that will be initially present. So that means m will be m by 2. Now again after the second half-life, it will be again reduced by the factor of 2. That means it will again become half. So that will be m by 4. Now after one again half-life, what will happen? It will become m by 8 because it is becoming again the half of the initial. So finally this m to m by 8 has been reached by the time t1 by 2, t1 by 2 plus t1 by 2. That means 3t1 by 2, 3t half, 3 half-life. So that means after 3 half-life, this m has been reduced to 1 by 8 of m. So basically we were doing this thing to find out this 1 by 8 m, we have done that. So now to find the time, we know that it has been converted to m by 8 after the 3 half-lives. So that means if you are going to multiply this 3 multiplied by the half-life, that is 1.4 into 10 raised to the power 9. So you will see that it will come out to be, because 14 3s are 42. So 4.2 into 10 raised to the power 9 year. This must be the time at which the mass will be reduced by m by 8. Again here you will see this is m by 8. So it has been reduced after the 3 half-lives. So that means this must be the time period. So let me just verify whether this option is present in the options or not. 4.2 into 10 raised to the power 9 year. So yes, this is the correct answer, because we can see this is just and accurate with the answer that we have got there. That means the age of the rock will be 4.2 into 10 raised to the power 9 year, right? We have done this question now, and we will be now proceeding towards the next question. That will be the question number 8. So the question number 8 before me, I can see that in a radioactive material, the activity at time t1 is R1, and at a later time t2 it is R2. That means at time t1 it is R1, at time t2 it is R2. If the decay constant of the material is lambda, then which option is correct? We have to choose any one correct answer. So we will be now doing it. How to proceed it? We know that we can represent this activity by one relation, that is R equals to lambda n. Now because we have been given at time t1, our activity is R1. At time t2, the activity is R2. So I can write it as R1 equals to lambda n1, R2 equals to, let me just not write in this way, because now I know that n equals to what? n naught e raised to the power minus lambda t, isn't it? These are the two relations that you know is important from the chapter radioactivity. So now because you know that n equals to n naught e raised to the power minus lambda t, just put this value of n into this equation and we will be having r equals to lambda n naught e raised to the power minus lambda t. Now they are saying that at time t1 r equals to r1. So that means r1 will be equals to lambda n naught e raised to the power minus lambda t1. And for the r2 it will be lambda n naught e raised to the power minus lambda t2. Now because I have to, I can see that this must be the ratio of r1 and r2. We have to focus on the options now, because what we want, we just want the answer in the form of the options that has been given. So we should not only focus on the question, we should also focus on the options that are available. If you are focusing on the options, you must be having an idea of approaching to the answer, right? So I can see that if there are r1 and r2, that must be the ratio of r1 to r2, because I am having r1, I am having r2. If I am going to divide these two, somehow I will be getting these relations. Now let me just tell you one thing, I can represent this activity also as r naught equals to lambda into n naught, because we know that r equals to lambda n. I can also say that initially r naught will be equals to lambda into n naught. So that means if I will be putting lambda n naught in place, I will be putting r naught in place of lambda n naught, that will become r naught into e raised to the power minus lambda t1, and this will become r naught into e raised to the power minus lambda t2, isn't it? What I have done? I have just put r naught in place of lambda into n naught. Now the equation will be, if I will be having r1 upon r2, you will see that it will be r naught into e raised to the power minus lambda t1 divided by r naught into e raised to the power minus lambda t2. Now just solve this, r naught cancelled, you will be having e raised to the power minus lambda t1 plus e raised to the power minus lambda. What I am doing, because this is in upon, this is in denominator, what will happen? E raised to the power minus lambda t1 minus lambda t2. Now if you will be taking lambda as common, you will be having t1 minus t2, and so you can also represent it as r1 into r2 e raised to the power minus lambda into t1 minus t2. Is this correct? I think there must be, because there is minus lambda, it would be plus. When it will go up in the numerator, it will become positive. So e raised to the power minus lambda t1 plus e raised to the power lambda m2, lambda t2. So if you are going to just take a common of the decay constant outside, your relation will be somewhat like this. So I am having this relation as this. Now I have to verify whether this is present in the options or not. I will just again check r1 equals to r2 into e raised to the power minus lambda t1 minus t2. Yeah, so I can see this, but yeah, we have to e raised to the power minus lambda is also there. So this must be the correct answer. r1 equals to r2 into e raised to the power minus lambda into t1 minus t2. You can verify from here, and you can also see what we have got here. This is the correct answer. So yeah, we are done with this question. The only thing, the important thing of the question, the beauty of the question was only this formula. One this and second this. If you know this, you are able to sail your boat. Now we are going to proceed to the next question, and we will see what is the next question that is coming in front of us. Alright, so I can see that there are two radioactive substances A and B which is having their decay constants as 5 lambda and lambda respectively. At time t equals to 0, they have the same number of nuclei, and the ratio of the number of nuclei of A to those of B will be 1 by E square after a time interval what? That means what we have to do? This I have just read orally, but now what we'll do? We will understand the question. First of all, what we have to do? We have to find out the time, and we have been given the two decay constant, that is 5 lambda and lambda. At time t equals to 0, the ratio of nuclei of A to the B is, let me just write what has been given, N1 upon N2 has been given as 1 upon E square. This has been given in the question, right? Now what I can do is, I know one relation, one important thing, this relation, right? So for the first radioactive element A, decay constant has been given as 5 lambda. So our N1 equals to N naught into e raised to the power minus 5 lambda t, because we are doing it for at a particular time interval. So for second, that means the B, the radioactivity relation will be N2 equals to N naught e raised to the power minus lambda t. Now what we can do from here, we can just find out a relation of N1 upon N2 from here. So suppose this is equation number 1 and this is equation number 2. To find out this ratio, what we will do? N1 upon N2 is equals to N naught e raised to the power minus 5 lambda t divided by N naught e raised to the power minus lambda t. Now what you can see from here, N naught cancelled, and you are having e raised to the power minus 5 lambda t plus lambda t, because this minus lambda t will go up in the numerator and it will become positive. So you are having your N1 by N2 as e raised to the power minus 4 lambda t. Now because this is minus 4 lambda t, if you will be just making it into denominator, it will become positive. So you can write it as N1 upon N2 equals to 1 upon e raised to the power 4 lambda t, isn't it? Now we have been given this relation, that means N1 upon N2 equals to 1 upon E square. So if I am going to equating these two, this is also N1 by N2, that is also N1 by N2. So if that is also N1 by N2, if we are going to compare them, we will be putting this N1 by N2 in place of this. It will become 1 by E square equals to 1 upon e raised to the power 4 lambda t. Now because this is 1 by E square and this is 1 upon e raised to the power 4 lambda t, exponentials are same, so we can compare these two. So that means your 4 lambda t will be equals to 2. Your 4 lambda t, this will be equals to this 2. Now what you will be having, because we have to find out the time. So your time will be 2 upon 4 lambda, or you can say your time has came out to be 1 by 2 lambda. So we have found out the time by our method. Now let us just verify whether this time that has been came is correct or not. So time equals to 1 by 2 lambda, and just see, go back to the question, and yes, I can see the option number D is the correct answer. So that means you must be having one correct approach to the question to reach at the accurate answer, right? So now we are done. We have just covered this question. We are done with this. Let us just now proceed to the next question, and this question is going to be the last question from this pattern, and then we will be moving further. So here I can see that the volume occupied by an atom is greater than the volume of the nucleus by factor of about what? We know that what is the order of radius of? What is the order of radius of atom? What is the order of radius of nuclei? So we are going to use that order of, we have to find out the volume, order of radius of atom is, you can just use the approximate sign over here. It is 10 raised to the power 14, and we know that order of, it's 10 raised to the power minus 10, and order of radius of nuclei it's approximate to 10 raised to the power minus 15 meter. Now because we have to find out the volume occupied by an atom is greater than the volume of nucleus by factor of what? So if we are having the volume of atom to the volume of nuclei, it will be 4 upon 3 pi r cube, because volume of atom and volume of nucleus is same, that is 4 by 3 pi r cube. But yes, radius is going to be different. The formula is same, but the radius will be different. So 4 by 3 pi r cube. Now your r for this will be, let me just write it again, this will be r dash cube. This r is for atom, this r is for nuclei. So if you will be going to put the value 4 by 3 pi are same and constant, so you can cancel them out. You will be having the ratio, the relation between r cube and r dash cube. Your r cube is 10 raised to the power minus 10 divided by 10 raised to the power minus 15, its cube. Now if you will be solving it, you can see that your answer will be coming out into the range of 10 raised to the power 15 meter, because it was the order of radius of atom and nuclei, and if you are going to solve for them, you will see that your order will be in the range of 10 raised to the power 15. I can remove this meter sign from here, this unit from here, because I am just talking about the order. So basically the order has came out to be equals to 10 raised to the power 15, and you can use it, you can just verify it by using the calculation of this. So yeah, we have done, we are having the answer 10 raised to the power 15, and yes, I can see that option number B, that is 10 raised to the power 15 is the correct answer. Yeah, we have now covered all the questions from the NEET pattern, and we have done the theory of the chapter. Till now just we have covered all these things. Now I just want you to wish all the very good luck to you, so that you can keep practicing well on the regular basis. You just keep revising well on the regular basis, so that you will be succeeding, because I know that your exams are nearby and you will be in hustle and bustle to just prepare for your exam. So to prepare well, you should be just stay fit and eat good food and just practice regularly. That's it. That's what I can say you. Just keep practicing. Just stay safe. Take care. Bye bye.